Okay, so here is the last topic of the year, hopefully, unless I find something else I want to do. So we're going to look at optimization again. We did optimization earlier in the year. I just want to review it because I'm going to add one little thing to it. And this is something else I believe we did, but I just want to make sure that you understand. So optimization is looking at optimizing the area, so biggest area with smallest perimeter. The best shape for this, and we're talking 2D right now, the best shape is a circle. Okay, that's the best shape. Then if you really want to get technical, the next best shape is like 100-sided shape and then 99-sided shape. The best practical shape is usually a rectangle, but a very specific rectangle where all the sides are the same. Okay, or a square. So a square is usually the best. Now, with that being said, if I had 40 feet in perimeter of fencing, to find my best shape, I would just divide this by 4, which would give me 10 feet per side. So it looks like this, 10 and 10 and 10. Then we build off this after. So if we had a shape that was two-sided, we just take the perimeter, divide it by 2. So if we had that 40 feet of fence again, we divide it by 2, which would equal 20. So that'd be 20. Okay. Then lastly, if I had something where it's 3-sided, I do not do perimeter divided by 3, although if you remember we tried that, which actually is you go perimeter divided by 4. Let's do it here. 40 divided by 4 equals 10. That would make our sides 10. Actually, our length would be 20. So this would be like L, L, and this one would be 2L. So there's a review of what we've done before. Now, what if I gave you an area? What if I told you I need an area of 144 meters squared? What's my best dimensions? How are we going to find that? I think we did this already, but just in case we forgot. Well, if you think about it, area equals length times width. As we discovered before, the best shape is a square. So the length and width are going to be the same. So I'm just going to name this S for side. So an area is going to equal side times side, which is going to equal S squared. Now, we know our area, 44, equals S squared. Now we can just solve for S by taking the square root. So square root of S squared is going to be S, and this is going to be 12. So our sides of this would be 12 and 12. I'll let you do this. I have a shape that I want the area to be 625, but I want to minimize the amount of fencing I need to put up there. What would be my side lengths? You can pause it here and give it a shot. Now for people who unpause it or chose not to pause it, area equals length times width. Area equals side squared. 625 equals our side squared. Take the square root of both sides. Side is going to be 25. So my shape will be 25. Let's erase that. My shape is going to be 25 by 25. Okay. So that's how we're kind of doing our 2 dimensions. Now 3-dimensional shape, our best shape here is a sphere. Our best shape is a sphere. Okay. So another shape we usually work with is a rectangular prism. And the question would be, what type of rectangular prism is it? What dimensions would it be? Well, if you look back and said, okay, our dimensions for here was a square, the square of a rectangular prism would be a square prism. So if I were to write dimensions here, right, as a horrible artist, it'd be 10 by 10 by 10, or x by x by x. So I could give you, let's say, the most simple one, I want a prism that is 1,000 meters squared, cubed. That's the volume I want. Well, volume equals length times width times height. If you look here, all my length and width height are the same. x3, so that'd be x times x times x. So to get the answer for my dimensions, I would have to take the third root of this number. And the third root of this number just happens to be 10. Right? 10 by 10 by 10 equals 1,000. Okay? So that would give me my optimal dimensions. Now something pretty interesting here is a cylinder. And I just learned this for past a little bit. If I were to design a cylinder, a soup can, whatever you would say, the most optimal soup can is where the height equals double the radius. So if I had a soup can of like 40 centimeters high, right? It's a pretty big can actually. 40 centimeters. The optimal shape for that, for reducing the surface area, would actually be a radius of 20 centimeters. It's almost making a rectangle anyways, right? So there, in that case, h equals 2r would be a key point there. So let's say I had if I as a manufacturer had a soup can. There's my soup can, wonderfully drew. If I had a soup can with a radius of 10, what would the height be to go with that? Well, the height would be double my radius, so my height would be 20. And go from there. The big thing here is this part here. So there's a quick review, right, of optimization. It's something new, but I think we touched on rectangular/square prisms before. It might have been an extension question with some students. But there's optimization, as we've done before. Okay, you can work on your worksheet, and that is it for today.